Hello everyone and welcome to this course on test-driven development with JUnit. This is Melrick D'Souza and I will be your instructor for this course. Test-driven development is a very widespread practice in the software development community due to improvement in software quality and shorter software release cycles. In this session, you can learn more about practicing test-driven development in the Spring framework. In this session, I will explain the importance of practicing test-driven development using the JUnit test framework. I will also give you some hands-on practical advice to apply this skill in a Spring Boot application. So in this session, I will explain the importance of practicing test-driven development using the JUnit test framework. I will also give you some hands-on practical advice to apply the skill in a Spring Boot application. By the end of this session, there will be a written test for you on some of the major component stereotype in a Spring Boot application, including Spring controllers, services, and data repository components. Now let's get started. Hello students and welcome back. You need to have certain skills and knowledge if you want to be successful in this session. At least an intermediate understanding of Java development, a basic understanding of Spring and Spring Boot is needed. You need to be familiar with certain design patterns and concepts such as model view controller, inversion of control, and service-oriented architectures. You must be able to use some tools and should also have them. There are Spring Tools Suite IDE, the MySQL Community Edition database server, and the MySQL Workbench, graphical utility for working with the MySQL database. All these tools are available for free online. Thank you for watching this video. We will see you in the next upcoming video. Hello students and welcome back. We will see why test-driven development is important before we get started on practicing some test-driven development ways. There could be many reasons, but I will condense this to the most important ones. It is one of the best ways to get quick design validation. As a developer, when you write code for anything, first thing you do is to come up with a design. Whether you formally document that design on paper, but it is true that design happens before development. You need to test your design because it's pretty expensive to change and implement bad design later in the development cycle. By practicing TDD, you will get the quick design feedback you need and will be able to fix a small problem before it becomes a big one. A good test coverage is what I would like to call executable documentation, the best documentation you can have on a software application. Tests are the most trustworthy documentation because they give you facts and not just opinions of what other teammates believe or what other documentations say about the system. Tests are also a good place to begin documenting a feature's acceptance criteria. When you start writing automated test code for the first time, test cases are the ones where you verify that all the acceptance criteria have been met for a feature. Automated tests, especially unit tests, are useful to verify the parts before the whole. Considering that many teams often develop different aspects of a feature simultaneously, it's a great thing to be able to vary each part independently before it is integrated with other parts and make up the whole feature. Another reason is that it is good for change management. One cannot change what one does not understand. This saying holds good for writing code. Test coverage enables you to understand code before you change it. Reading and running tests, especially for code you did not write, will help you understand it, and so you'll be able to start making safe changes. Similarly, TDD is a useful tactic to be employed for troubleshooting defects. Writing tests should become a habit for every troubleshooting effort. The test you write can serve as a useful artifact and can help when defects reoccur. They also help with onboarding and training new developers in a team. A new developer can contribute to writing of tests for features, assuming those tests are written in a safe way. Writing tests can be used to train a new developer. This allows the new developer to learn what the system does by taking advantage of the executable documentation and contributing to it as well. The final reason is that practicing and able to prove test-driven development is definitely a next-level skill set. It is good to have this skill on your resume, and it helps you stand out from the crowd in your job search. Most often it's mandatory or an important part of team culture to practice test-driven development. You will be seen as a team fit by having this skill on your resume. You will be considered as one who possesses leadership skills by hiring managers and your future teammates. You need to master test-driven development skill if you want to improve your job opportunities and possibly your compensation. It would definitely take a lot of practice to master this skill. So let us get started on this, and it's time for some hands-on practice. Thank you for watching this video. We will see you in the next upcoming video. Hello students and welcome back. So in this session we will talk about how to plan for testing service components. We'll start testing the business logic layer of a Spring application. Hope you remember that we are working on a fictitious e-commerce web application for a flower shop business. We will add the first automated test written for this application. If your team decides to practice test-driven development, then probabilities are high that they also practice other ways that stem from an agile methodology, such as writing user stories to start planning feature development. Let us review some user stories before we get into writing tests. We had an add contacts feature in the prior release that we allowed the user to create contacts to their account and start an address book feature. We are working on release 2 of the system, where we will take the add contacts feature a step further, and we will add something called contact occasions. This allows the user to add birth dates or other special dates so that someone can receive flowers on those dates. We'll go back to our architecture just to show where we are in our testing process. Now we'll start writing tests just for our Spring Services components. We are beginning with service components because that is where some of the important business logic is implemented. Services are where test coverage is typically needed the most. And speaking of priorities, we should spend some time thinking of our test goals and objectives. This helps to manage the overall time and spend time thinking through a plan of action before we go straight to writing test code. You need to have a specific plan for how you will spend your test time. Not all things are equally important from a testing perspective, so be clear on which components and which features need test coverage. So for example, you may decide that happy part tests are first priority. So let us look at the test plan for H and P service components. This plan should include deciding which type of tests are needed and on a per future basis. The test type could depend on timing and where you are in the development cycle. We will write both integration test as well as unit test for the H and P application. As the add contacts feature is so subtle in production, it's a great place to start writing integration test. It is both easy and possible. Every component which has to be involved in the integration test is already mature and settled, so they are perfect for an integration test. However, the new feature add contact occasions has no code written, so it's a key candidate where we can focus our unit test efforts. At some point in the development cycle, it may be good to finish up the add contact occasions by creating an integration test for it. But now, let us start writing some tests. Thank you for watching the video. We'll see you in the next upcoming video. Hello students and welcome back to another session. So before we start writing our first test, let us understand our test objectives. So we'll look at the visual representation of our test goals. So hope you remember that we are doing an integration test of our contact management service. So we'll start writing our first happy path test case, where we are testing how to add a new contact to our address book. So as this is an integration test, it involves exercising the interaction between the contact management service and the contact management data access components. So we need to consider a bit of special JUnit and Spring set up before we start testing. So we'll preview some of the things that we need to do. So as we are testing services and its dependencies, we're not going to run any controller components, but we are just testing our service components and our data access components and how these two interact with each other. Since we are using real data access components, we will connect to a real data source, so which could be test-specific data source or other database environment. So for this exercise, we'll have a Spring project set up with the familiar Spring project layout. So there's a production source in the source main Java tree and a test source code in the source test Java tree, which I'll expand now. We are concerned only about testing our service components now. So there is a service package. So there we have an integration test, which I will open. So we need to instruct JUnit that we are testing a Spring application. Okay, type in that. We do that by adding the @run with annotation. So the next thing we would do is let JUnit know that we are not only testing a Spring application, but this is Spring Boot application. So we'll add the @Spring Boot test annotation. So let the JUnit environments bootstrap all the required Spring components. As we are only testing our service components, we also want to instruct JUnit to just load the components that are needed and ignore the ones that we don't need. So we do this by adding the web environment attribute. So we'll tell it exactly what kind of web environment we want to load during our test. So here it's none, so this means none of our controller components will be loaded. So in our example, we don't have any controller components to begin with. But in a real world scenario, this could become very useful when you want to ensure that only what you need gets loaded during the test. So the next thing I want to point out is we have our context management service, auto-wired, which is the component that we actually want to test. So we want to make sure that it is a field on this test class. So now we'll begin our first test, which is the add contact happy path. The first thing we need to do is create our contact. And for our testing, we'll set up a few properties on this contact. So let's give our first contact a name. So let's call it Jenny. So we'll give a last name. We'll call her Jenny Johnson. So we'll stop with this. But in real test scenario, we may want to set more attributes such as address, phone number, email, etc. Now we'll call our contacts management service and save the record. We're going to call the add method on our contacts management service. We will pass in the new contact that we just created, and it should save. Okay, we really want to see what gets returned from that save. And this will be customer contact, object, but a new object. It's getting interesting now. So we want to compare what we send in with what we got back. So that is, we want to compare a contact with the new contact that was saved. So we could do this with JUnit by creating a set of assertions, as many as useful for your test needs. So there are a few here ready to go. So these are kind of basic ones, but there is a pattern that you will see here on the things you want to assert. So the first thing I want to assert is that the new contact is not null. So is to make sure that the object that came back after the save actually got saved. The next thing to assert is that the new contact actually has an ID. The final assertion that I would like to make for this example is just a simple comparison. I want to assert that the record saved was actually Jenny's record. So I want to see if the first name for the new contact is Jenny. This assert equals JUnit assertion does a simple string comparison between what I expect and what was actually returned. So now let's run this test. So I'll right click on the test add contact happy path, my Explorer window, and then I'll run this as a JUnit. And I would see the green bar when it's done. Okay, now that's what we are looking for. This indicates that your test and all your assertions have held true. So if something went wrong, this will be red. And so you may have to go in and troubleshoot either your test code or your actual production code. So let us do one final check. So we'll see what is there in the database. Now I've moved over into the MySQL browser, which will allow me query tables on my database and see what happens in any of my tables. So right here I have a select statement. So I want to select the customer ID and the first name from my customer contact table. So I want to see Jenny's record in there. There she is. I ran the select query and I could see one record which has Jenny's first name, Jenny's last name, and her ID. So this is what I wanted to see. And now we can get back to writing more tests. So let us review this session now. We provided JUnit and Spring some important bootstrapping directives so that the test could run with all of the Spring components needed, and at the same time we ignored the Spring components that we did not need during the test. We created our contact management service integration test, and we added test coverage for the add contact feature. We saw a green JUnit bar to ensure that our test was successful. We verified in our local MySQL database that the new contact record was added. And finally, we have now paved the way to write more service integration test cases. So thank you for watching this video. We will see you in the next upcoming video. Hello students and welcome back to this course. So we will come up with a test plan for our controller components. As we did with our service components, there should be a plan in place to test our controller components. Let's go back to our architecture overview just to have a sense of where we are in our testing. We'll be testing Spring MVC controllers. Now let's go over some specifics of that plan. As we came up with some very specific ideas and objectives for our integration testing, we should repeat the same for controller testing. The questions we asked before stay the same. However, we need to ask one additional question while testing our controllers. We should know if we are testing MVC style controllers, REST style controllers, or possibly both. This really depends on our application. Just to make things clear, the only difference between MVC controllers and REST controllers is the output that they return to whatever code caused them. So for example, in MVC controllers, they usually return a view model object to some type of a web page or HTML page that knows what to do with that model. On the other hand, REST controllers tend to return a JSON or XML response. For our illustrations, we will get test-driven development practice focusing on MVC style controllers only. Just as we did earlier, we will stick to our familiar scenario of testing our add contact behavior for a new contacts management feature. Thank you for watching the session. We will see you in the next upcoming video. Hello students and welcome back to this course. So we are now ready to write our first integration test for a controller component. So let's do a quick review of our objectives now. Now note that this is an integration test. So all the components are real and no mocks are involved at this stage of testing. So you'd like to know what happens when a real contact management controller interacts with the real contact management service and when that contact management service accesses real data access components. So this is another preview on what we have to tell JUnit to do. We ideally want it to do everything. So we basically want the JUnit environment to provide us full servlet engine or web environment behavior. We also want to load all the types of components, controllers, services, and our data repository components. So let's begin. For the purpose of this exercise, we will test a controller that is located in our source test Java tree, like all test code. So we'll also look to expand our controller package where we have ready to go contacts management controller, and this is an integration test. So to read this a little easier, let's expand the window. So as we can see here, our run width annotation is the same as before. The Spring Boot test annotation is similar. However, the difference now is our web environment is no longer none. So we ideally want to simulate a real web environment with the real servlet engine running. So we'll choose a random port as it works fine for us now. So in cases of actual testing, we have the liberty to change this to a real port if we are working on an environment where certain ports are already in use and we want to avoid conflicts. Just as earlier, we should make sure to inject in the actual controller class we plan to test. So we shall begin with our add contact happy path test, where we set up our usual customer contact with Jenny Johnson's information. So we'll now call our contacts management controller. Let's begin the test and see what happens when we send in this Jenny object that is already set up. So we are basically simulating a customer contact form that was posted. So let's imagine a form on a web page where the user has entered the first name as Jenny and the last name as Johnson. They have hit the submit button and that sends in this form bean. Another thing to note, on our controller method, we expect a specific outcome. So right now it's just a simple string. For the purposes of this simple exercise, we could imagine how useful it would be if it were a different type of object. So let's do another thing over here. Unlike earlier when we were using assert equals a lot of times, we will show an improvement that was made to the JUnit framework a few years ago, where instead of assert equals, there are more expressive assertion methods. So for example, assert that outcome is equal to, so we are expecting a string that comes back and says success. And now this one example completes our controller integration test. Now let's minimize the window again and expand my test class. And right click on the happy path method because we just want to show what happens when we run that. So we're certainly hoping for the JUnit green bar. That's what we would love to see. Another thing we want to show you in this test class is that this is our first time testing a not so happy path. So let's imagine this was an add contact scenario where the user forgot to type a first name. So in our system, we ideally want the first name to be required information from the user. So in case they miss the first name, we expect the outcome to be a message that says failure. So we have done the same assertion as above and assert that the outcome is equal to failure. So now we'll run this test and see what happens. Okay, now this is interesting. The failure scenario test failed. This just shows how running JUnit's test and having the right kind of strategic assertions helps inform better design decisions. So at this moment, let's switch out of writing JUnit code and begin writing production code since we spotted a design flaw over here. We expected a failure outcome and we didn't get one. Now let's go back into our package explorer here and verify why this may have failed. We have a suspicion here that it could be in our service component. Now look at that. A new contact comes in and all we do is save it. What we should do is to check one required piece of information. So for the purposes of this illustration, we just need the first name. So what we'll do is first see if the first name is not null. In case it's not null, we then want to call the save method on my customer contact repository. So as we are checking that my first name is not null, before doing a save, we are also designing this code so that if the first name is null, we just want to return a null object. It may not be a bulletproof, but for this exercise, it'll do. Now let's minimize this window again and try to run that test that just failed. We expect my failure scenario to be caught, which means this test should succeed. So we are hoping for the green bar this time. So we have two test cases that are succeeding. Okay. So in the process, we have also seen how a failure test case scenario is driving us towards better design decisions. So this is pretty much the whole point of writing JUnit tests to begin with. So we would like to stay in cycles of writing tests that fail. So this way we can fix designs and then come back and see those tests succeed. So we'll now recap what we just accomplished. So we created a contacts management controller integration test. We ensured there was test coverage on our happy path for add contact. We added a test case to verify one specific failure scenario. And this was the scenario where a user forgot to type in their first name. After we wrote that test and see it fail, we took time to adjust a bad design decision due to a test outcome. We then revisited that test and ran it again to see it succeed. So this is precisely how we wanted the cycle to go. So we are at the end of this session. Thank you for watching. We will see you in the next upcoming video. Hello students and welcome back to this course. So we learned to write some unit tests for Spring controller component. But before that, let's first review our unit test objectives. So we'll write a contact management unit test class where we will test adding a contact. So we shall isolate our test to just the contact management controller, which essentially means that we will mock out our contact management service. So there's a bit of setup as usual. In order to preview what that is, we should mimic or mock some web browser behavior. We want to instruct our test environment to load our controllers. We should also instruct our test environment to just load mocks for our service components or anything else beyond a service layer. So let's begin. So in our Spring project, let's go into our source test Java tree and go to our controller package. Now let's open up the contacts management controller unit test and double click to expand this window. So let's walk through the setup a little bit. The @MVC test annotation is new for our setup here. This lets our test environment know that we will be unit testing an MVC controller. So we'll also add a mock bean for our contacts management service since we want to mock out the service component completely. So note that we are just focusing on unit testing our controller. So we should then inject mocks onto our contact management controller. We need to ensure that annotation is added. So there are some setup needs where we are just initializing our mocks. Now let's scroll down to our test case over here. The test for add contact happy path begins by just setting up a mock customer contact record. So this is the record that the mock business service returns us. So for now, let's add just a simple amount of information. So we'll give a first name to this contact. Now we have a contact for Fred. So next thing we shall do for our setup is mock out the business service, returning this contact to us. So we'll call on the mock business service. Whenever a customer contact is added, it just returns the mock contact record that we just established. The next thing we should do is simulate the form bean that would post from the web browser. Okay, now we'll set up some information that might be in that form bean. So this is the sort of thing that a user might type into a web form. So they could type Fred's name. So we'll add something else here to make this a little more interesting. So we'll give Fred an email over here, fredj@myemail.com. So this is basically simulating what a user would type in a web form. So the next thing we shall focus on is to show how we use the mock MVC framework to simulate posting this form or submitting this form to the controller. So in the mock MVC component, we shall call a perform or post. We will send in the contact form bean. So let's copy the name of that class. So we'll pass that into my post. So we'll then do something in the Mockito framework, which would be equivalent to assertions. So here we need to set up what we are expecting. So we're expecting status code of OK because this is a happy path test. So we're also expecting a return that completes a happy path scenario. So let's minimize this window and run this test. Let's go back into my package explorer and right click on my test for add contact happy path. Now let's run as a JUnit test and wait for that lovely green bar to appear. That's what we have. Now let's take this test one step further. So we have a happy path over here. So let's consider an unhappy path. So we have started a test case called as test add contact biz service rule not satisfied. So we want to simulate a scenario wherein the user forgets to type in a required piece of information such as the first name. So what would happen then? So when it comes to the business service implementation, a business rule violation should result in a null object being returned. This is the reason why we have simulated that scenario over here. Whenever a customer contact is added, just return null. So let's now move on to simulate what the user would enter into the form. We have forgotten to type the first name. So let's just enter a last name here and scroll down a bit here. Scroll down and we'll copy the name of this variable. So this is because we want to send that into my form submission and we expect a status of not OK this time. So we know that this controllers are implemented to return a redirect to the user. So we also happen to know that status code is a 302. Hence we expect a 302 code to be returned to the browser when a business rule is violated. So let's save this test and minimize the window and let's run that test. So let's go back into my package explorer, right click on the test, run it as a JUnit. So we'll wait for that green bar and we have got what we wanted here. Now we'll look at one last simple thing over here. So this is something we have started which you can complete. So we are now in a position to write more unit tests. So remember that there is a new feature coming. So we can now write the test for add contact occasion. So let's review what we just did. So we just illustrated how we can do some pretty in-depth controller testing without even starting a web server. We can do this by just using the mock MVC framework to mock out all of the controller's interactions with a web server and a web browser. So we showed that we can unit test a controller's behavior with the mock server as well as mock service components. So this basically implies that a controller can be fully developed and tested independent of the service component it relies on. We also saw that the controller's viewpoint routing is to send the user to the correct web page or redirect when it's supposed to do so. With the benefits of mock in the right places where we needed them, we could add test coverage for the existing add contact feature. We also had just enough groundwork laid so that we can begin adding test coverage for the new feature add contact occasion. So we are now in a position to stay in flow when it comes to writing test code, then production code, then test code, and so on, while all the time keeping the test-driven cycle going to drive a single component to completion. So that's all for this session. Thank you for watching. We will see you in the next upcoming video. Hello students, and welcome back to the course. We will now make a plan to test our repository components. We write these components so that we can have access to a data store. We will have a quick look at our application architecture overview. This just gives us a roadmap of where we are in our overall test plan. We are just focusing on testing Spring Data Access components. As is the case with other test plans, we have to ask ourselves the usual questions such as what are our highest priorities? What kind of tests are we writing? Are they unit tests? Are they integration tests? Are they both? As far as the persistence layer is concerned, we have an additional question that we should ask ourselves in the planning. Will our code access a relational database, a graph database, or both? These are some of the things we need to keep in mind and plan for. For our particular exercises, we shall use a relational database. For our persistent layer testing, we will just focus on integration test. We will not be doing unit test. The reason for that being lack of return on investment of unit testing at the data repository layer of a Spring application, since it is the Spring framework providing a lot of what could be called the units. So for instance, a lot of the actual implementation for data repository class is already completed by the Spring framework. Unless we find ourselves in a position where we overwrite and customize a lot of that, it is enough to plan for integration test only. For these pretty pragmatic reasons alone, we shall concentrate on just testing the interaction between the data repository classes and the data store itself. We do this type of testing to ensure things like entity mapping, query semantics are fine, and any custom SQL statements, transactional configurations work as expected. Thank you for watching this video. We will see you in the next upcoming video. Hello students, and welcome to another session. So in this session, we will see how to write some integration tests for our Spring repository components. As this is an integration test, we will see how well our contact management data access component inserts or retrieves data into the database. So we need to do a bit of setup as usual. Since we are focusing only on testing our repository components, we will instruct JUnit not to load any controllers or service components, and we need to load JPA testing configurations. So let's get started now. So here in exercise project, I will move to source test Java tree and down into the data.repos package. So I'll open up this customer contact repository integration test and I'll maximize this window. So with regard to setup needs, you can see the very familiar run with annotation. The new one is the annotation for data JPA test. So this is a shortcut annotation which helps us in testing JPA code. One more new annotation we can see here is auto configure test database. So this will let us set up the type of database that we want to use for our testing. We can use the embedded database, or we can also use the data source, which we have already configured here in our local environment. For simplicity, this is the one I'm choosing. I want you to notice that we are injecting our test entity manager, and you will see why this is useful in some time. So we are also injecting the customer contact repository component, as this is the component we want to test. The test case that we're working on now is the test find by email. I will set up a scenario where we are creating a contact that has an email address. So I'll enter the email address. tech@myemail.com, and I'll copy this email address. Okay, you can see the line of code here where I can test my find by email or my customer contact repository. So I'll paste the email address over here. So this is what I want to find, but I have to make sure it is there in the database. So to do this, I will use our entity manager, which allows me to directly save this new contact. So this new contact with this email address is going to be saved directly by the entity manager. So I have my line of code set up where I'm calling the find by email on my repository. And then I have an assert which is already set up. So I'll copy and paste this email over here. Now I'll run this test now, and I expect to see a JUnit green bar. So I'll go to my package explorer, then expand my test class and right click on the method that I want to run as a JUnit test. I run it and wait for some time. So we can see the green bar over here. That's exactly what I wanted to see. So I saved a new contact and I could assert that it was there, and I got what I needed. So we'll do one last thing. We want to verify if our database was left in a good state. So you can see a query ready here. So I'm going to select the contact ID, contact first name from the customer contact table. So we'll run this query and we get back nothing but an empty result set. So this shows that we could run a test that altered the database, and by the end of the test, the database was rolled back to its original clean state. Okay, so let's review what we have achieved over here. So we created a test class for our data repository. It was an integration test. We configured a test database with the transactional behavior. We asserted our test database record by accessing the test entity manager. This allowed us to test whether our find by method was working. It is also a form of entity testing. So it tested customer contact entity. So here we are making sure that all of the mapping is correct between an entity and the table that it represents. However, a lot more happened, so we'll review a little deeper. The data JPA test annotation packed a lot of magic in one single annotation. It can be called as a combo spring annotations, which is a quick way of adding a whole bundle of annotations that tend to go well together. So you can see a few here in the list, but actually the data JPA test annotation is a shorthand for several more. So let us look at the ones that we benefited most from. So first we have auto configure data JPA annotation. This is a basic need here. So you're letting your test environment know that you're about to start doing a lot of JPA testing, and so you need to know all the components that make sense for this type of test objective. And next we have auto configure test database. This allowed us to specify what type of database we want to use. The options are an embedded database or porting to an external database, or accepting the default database which is already configured and found on our class path during execution of the test code. And the next one is auto-configure test entity manager. As you saw in the test example, we accessed an entity manager which allowed us to quickly create an entity and have it persisted in the database. And finally, we have transactional annotation. So this allowed us to have a rollback behavior so that we could expect the database in a certain state when the test began, and also know exactly what the state was when the test ended. So this means our tests are repeatable. When testing out the data access layer, repeatability can be difficult. So we would like to make sure we begin and end a test with the database in a known state. The Spring and JUnit combination magic has enabled us to do that. So yes, that's it for this lesson. Thank you for watching this video. We will see you in the next upcoming video. Hello students, and welcome back to another session. So in the previous lecture, we went through a pretty trivial example of creating test setup data by instantiating an entity object, setting values in it, and using our entity manager to hold that object in the database. Sometimes we too simulate a more thorough and involved data scenario to fully test data access code. And there is a framework for that, which is called DBUnit. And we'll introduce this framework in our next exercise. So DBUnit is a JUnit extension that helps developers manage the non-trivial task of keeping the data stored in a known state before and after testing. As expected, with any of our test classes, setup needs exist. And we'll have to load some DBUnit specific configurations for this scenario. So let's get started and see what it looks like. So in this exercise, let's go into our src test java tree as normal and into our data.repos package, and we'll open up the customer contact repository DBUnit test. Now take a look at the setup which is going on here. A lot is familiar, but few things are new over here. We have our test execution listeners, which are going to help us with the DBUnit setup. The final annotation is the one which is really giving us what we need, database setup, and we are referring to an XML file that we created with our test data sets. So let's go ahead and minimize this class for 1 second, and let's open up that test datasets file. So we'll go into our package explorer, and under src test resources is that XML file. And let's see what we have in here. This is some DBUnit specific information. So we are creating a dataset element, and inside that element we create an element for every record which we want to insert into the database to simulate the data setup needs that we have. Now for our test, we have some pretty simple needs. So we'll be simply creating 4 customer contact records. So we have one for Jenny, and we have added some more of Jenny's friends, Eileen and Susan and Bernard. So let's go back into our test class. Let's maximize this window again, and we will see that we have the test case ready to go here for us. Test find by email. So what we want to do is create a customer contact. In order to do that, we are going to rely on our customer contact repository. And we have a find by email method on our repository. And then we'll type one of the emails that we know exist in our test data set. So Eileen had an email address in there. So let's use hers. Eileen@myemail.com. So let's finish this line. And that's really all we want to find for this test. Let's also finish. Let's assert something over here. We'll do pretty simple assertion. We would like to know that the contact that came back from my finder actually has an email address. And because sometimes we want to be safe and not retype things, we'll copy and paste. Let's end this line of code, the semicolon. And now we are ready to run this test. So let's minimize the window here and go back over into our package explorer. Right click on Find by Email, Test Case, run it as JUnit test. Wait for a few seconds, and eventually we should see the green bar. And that's it. So notice what was missing over here. We didn't actually have to deal with an entity manager. We didn't have to create a fake entity, set some data into it. So all we needed was our test datasets.xml file, and from this we can imagine that when we have more thorough needs, we can create more information or more datasets file. So let's review what we have learned. So we created a DBUnit dataset in an XML file. We could completely specify the data scenario without creating entity classes, instantiating those classes, etc. So this is extremely useful when our project is at a point where those class types may not yet exist, or we may not be the developer responsible for making those classes. But we still want to start testing with creating scenarios in a database and testing how we find the data, or even testing how to insert more data. So we also covered some simple find by test cases. So in our case it was find by email, but hopefully that was enough to get an idea of the many possibilities beyond what we covered. So that's all for this lecture. Thank you for watching. We will see you in the next upcoming video. Hello students, and welcome back to another session. So in this session, let's turn our attention to creating test suites. So we are able to combine multiple test cases to run as a grouping. So this is also known as a test suite. Test suites here are very helpful to achieve a much broader testing objective. So some examples of test suites are smoke tests. These are the kind of tests that we might want to have in place just to give us a good indication of basic system health. There's also a notion of iteration test suites. If our project is planned in iterations, we may want to group the test cases for any of the work that's happening within an iteration. There's also something called a feature test. This is what we are going to do in our upcoming exercise. We will combine several of the test classes that we have already developed so that we can have a test suite for our add contact feature. So let's get started so we can see what that looks like. So we have an exercise project here, and we will go into our source test Java tree. So we have an add contact feature test suite, which we will open up. Okay, and let's maximize this window. We will see the familiar run with the annotation. What's new here is the type of runner we are using. So we are using a suite class. So this is letting JUnit know that we want to create a test suite, and we also have to supply the list of classes that we want to aggregate together. So therefore, for this particular test suite, we choose to combine the context management service integration test as well as the controller integration test and the repository integration test. And note that other than creating the class, there's no implementation. It's intentionally empty. All that's really needed is all of the requisite test suite setup annotations. So let's minimize our test class and run our test suite. So let's go back into our package explorer, right click on the add contact test suite so that we can run it as a JUnit test. Now there's multiple test classes involved here, so there's a little bit of a wait. So once that's over, we should see the JUnit green bar. But let's expand this JUnit tab. So I want to show you, maybe even prove to you, that our test suite actually ran the classes that we wanted it to run. Now let's expand. So it ran our context management service integration test. If we expand that, we'll see which particular test case. The add contact happy path we included in our context management control integration test. And if we expand that, we can also see that what ran. And finally, our repository integration test, which ran our test find by email test case. So let's shrink that down. So now for a simple test suite, we would say that was pretty thorough. So obviously our test suite needs will differ. So let's review what we have just learned. So we made a feature test suite for our add contact feature where we combined all the efforts that we put into creating integration test for a controller, our service and our repository components. We could have just as simply combined our unit test into a suite. The combination possibilities are endless but typically strategic. We would have of course make test suite aggregation choices that suit our project needs. So yes, that's all for this lecture. Thank you for watching this video. We will see you in the next upcoming video. Hello students and welcome back. So in this lecture, let's turn our attention to a kind of test suite which is very often employed by teams that are practicing test-driven development as well as other agile methodology habits. Then chances are high that this is the kind of a team that highly favors the use of a continuous integration process. So this basically means that there's a continuous integration server involved in the automated build and deployment processes. A single smoke test or a smoke test suite is a great thing to incorporate into the cycle of our continuous integration server. This is the kind of test which is run after every check-in. There could also be another kind of test which is run whenever a full deployment is about to happen. So let's get started on an example of a continuous integration test suite that we might want to make. So let's go into our Spring project. Let's drill down in our source test Java tree and open our root package. And we'll open the continuous integration test suite, which should have the familiar run with the annotations. And we're supplying a suite runner to let our unit know that we are running a test suite. And we also have to supply a list of suite classes, which as we notice now is empty. And we want to open one of the test classes that we have made simply for this test suite. So let's maximize the data store system's health test. So what we have here is a test called DB primary is okay. What I'm trying to suggest here that we might want to run a check against database systems or any kind of similar external systems that our application connects to. And we may consider that type of test a good indicator of overall system health. So for this test, we are simply getting a connection to our data source and asserting that the connection is not null and that the schema name is what we expect it to be, which is Spring TDD. So let's minimize this. And before we do that, we'll copy this test name. And now we are going to switch back to our test suite class and add our data store system class, test class to our list of test suites. And there's one other class we also want to add. So let's open the context management control integration test. So we're going to copy that class name and then once again switch back to our integration test suite. So let's paste the name of this class into our list. And now we are going to put a new line here just for readability. And let me explain why we are adding our control integration test. So this could be an example of the kind of feature in a system that if it were very settled, since it involves so many different components which are also very subtle, so running this test is a good overall indicator of system health. Now let's run our test suite. Let's go back to our package explorer, right click on our continuous integration test suite class. run it as JUnit test. So you're going to wait for all the test classes in that suite to run. Then let's see. We're looking for the green JUnit bar, and that's what we got. So let's review what we have just learned. So we saw a very simple example of the kind of test suite that we might want to fold into our continuous integration cycle. Because this type of test is attached to a continuous integration cycle, and we want to ensure it's pretty lightweight. So some teams run a full integration every 15 minutes, some every hour. So the timing of our continuous integration cycles is going to be a good guide for just how much we want to happen in our smoke test suite. It really comes down to our team's definition of what a smoke test is. So yes, that's all for this lecture. Thank you for watching. We will see you in the next upcoming video.